Continuing on with our study guide questions, we're going to look at some factoring problems that require a few extra steps. So on number 24, we have a coefficient in front of our first term. Step number 1 is always to look and factor out a GCF if there is one. In this case, we've got 4, 26, and 30. They're all even numbers, so we at least can factor out a 2. And then looking to see if they're all also divisible by 4. They are not. So 2 is our greatest common factor. So when we take a 2 or factor out a 2 or divide a 2 out of each of those terms, we're left with 2x squared plus 13x plus 15. Now this time, when we factored out a 2, we still have a leading coefficient in front of our first term. And our goal when we want to factor, we don't want a leading coefficient there. So what we've been doing is we get rid of that leading coefficient by just sliding it to the back. And when we slide that 2 into the back, we're going to multiply it by our last term. So x squared plus 13x plus 30. So then when we factor that into two binomials, because now we are happy, now we've got something we can factor because there's not a leading coefficient anymore. We've got x and x. Plus sign in the back means they're going to be the same sign. They're both going to be positive. Two numbers that multiply to 30 and add to 13, that's 10 and 30. But because we cheated math and we multiplied to get rid of that term in the beginning, now we have to undo that step. And in math, to undo multiplication, we divide. So we're going to divide both of these by 2. 10 divided by 2, that comes out nicely. It's x plus 5. 3 divided by 2, that doesn't come out as a whole number. And we can't reduce that fraction, so we take the bottom and we move it up. So it becomes 2x plus 3. And again, it doesn't matter if you have those two switched. You could have the 2x plus 3 in front and x plus 5 in back. But what we absolutely have to have as part of our answer is that GCF. So if there's a GCF, that's the number that we put out front. Looking at number 26, 16, 56, and 49 do not have a greatest common factor. The only factors of 49 are 1, 49, and 7. And 7 goes into 56, but it does not go into 16. So if we were going to use the method that we just used on 24, and we can do that, we can slide the 16 to the back and multiply, but when you take 16 times 49, it's going to give you a pretty large number that you then have to factor. So when that happens, check your first and your last term and see if they are both perfect squares. In this case, 16x squared is a perfect square. 4x is the square root of 16x squared. And 49 is a perfect square. The square root of 49 is 7. So this could be a perfect square trinomial. We've got a plus sign in the back, which means both of them are going to be the same sign. Minus sign means it's going to be minus minus. Now let's check and see. We said the square root of this was 4x. Square root of 49 is 7. Another way of writing that is 4x minus 7 squared. But we can't just trust that that was in fact a perfect square trinomial. We do have to check to make sure that the middle term works out. So to check that middle term, you could take these two binomials and FOIL it out or use the distributive property to do that. Or our shortcut is taking 2 times the front term times the back term. So like 4 times 7 times 2, or 2 times 4 times 7. And when we do that, we do get negative 56x. And so our middle term does check out. So this would, in fact, be our final answer. And I don't care which way you write it, as long as we've got 4x minus 7 times 4x minus 7. Right, like the last problem, we do have a perfect square in front and a perfect square in back, so we don't need to slide the 400 to the back. However, if you do look at this and say the square root of 400, x squared is 20x, and the square root of 4 is 2, you're missing a step. We always have to check for a greatest common factor first. And in this case, there is a greatest common factor. 4 actually goes into each one of those. So before you do anything else, if there's a greatest common factor, you must factor it out first. So when we factor out a 4, we get 100x squared minus 20x plus 1. Now that we've got this in the parentheses, you can go through the bottoms up method where you slide that leading coefficient to the back, and you're going to get the same answer. But just like before, when we had a perfect square in front and a perfect square in back, we still have a perfect square in front and a perfect square in back. So we can check and see if it is a perfect square trinomial. So same sign means they're both going to be negative. So you can write it out as 2 parentheses, or you can write it as a squared. The square root of 100x squared is 10x, and the square root of 1 is 1. Let's check the middle term first. So our middle term, we take 2 times the front times the back, so 2 times 10x times 1, and we do get the 20x, or negative 20x. So it does check out, and then we've got to keep our greatest common factor in front, and that would be your final answer. All right, so we've been talking and factoring a lot of trinomials, but this is just a binomial. And so far, we've only factored binomials if they are a difference of squares. Difference meaning there needs to be a subtraction sign, which there is, and squares meaning the first and the last terms both have to be perfect squares. In this case, they are not. However, first step of factoring, always factor out a GCF. And in this case, there is a GCF of 2. So when we factor out a 2, or use the backwards distributive property, we're left with 4x squared minus 1 in the parentheses. So we ignore that GCF for a minute. We're just looking in the parentheses. We've got a binomial. The only way we factor a binomial is if it's a difference of squares. We have a difference. 4x squared is a perfect square, and 1 is a perfect square. So this is a difference of squares problem. And if you forget how to factor a difference of squares problem, our middle term is missing. That means that our parentheses, when we FOILed, we must have canceled out those middle terms. And the only way we can cancel out middle terms is if one of the middle terms is positive and one of them is negative. Just like positive 5 plus negative 5 is 0, positive 4x plus negative 4x is 0, 100 plus negative 100 is 0. So they've got to be able, one has to be positive and one has to be negative in order for them to be able to cancel each other out. And then they also have to be the same. They have to be the same number, like 4x and negative 4x, 5 and negative 5. So in order for them to be the same number, besides that plus and minus sign, they need to look exactly the same. That's why they have to be perfect squares, right here and right here. So the perfect square, this is a perfect square. The square root of it is 2x. And 1 is a perfect square. The square root is just 1. Another way to think about it, to remember that one sign needs to be positive and one sign needs to be negative, is a minus in the back means you need one of each. So we have 2x plus 1 and 2x minus 1. We keep our greatest common factor out there in front. And final answer.